In this video, we're going to look in more detail at the concept of zero pairs. But first, let's look at what zero means. Many believe that zero just means nothing and has no value, as it represents no quantity or amount. But zero is a really important integer. Throughout history, there has been much debate about how to represent a value of nothing, and it's been done in different ways. Some historical civilizations simply left spaces or gaps. But later, symbols were used when people realized they needed something to act as a placeholder. In English, we use this symbol to represent 0, 0, or nothing. When children first learn about number and place value, it's essential for them to understand that 0 has an important job at keeping all the digits in the correct place value columns and show where there are none of a particular value. For example, the whole number 305 means 3 hundreds, 0 or no tens, and 5 ones. In the decimal 0.03, where there are no ones and no tenths, but there are 3 hundredths. 0 also has another important job, which is to separate positive and negative integers. When pupils are introduced to the concepts of numbers below 0, they learn in the context of temperature or other real-life situations, such as distances above and below sea level, or perhaps as simply as using a lift to move up and down between floors. When performing simple calculations with positive and negative integers, number lines, including vertical ones that are used as a thermometer, can help to scaffold children's learning. However, in secondary school, when pupils are taught how to add, subtract, multiply and divide negative numbers, it can be quite hard for people to grasp these rather abstract concepts. Concrete resources are often used to act as physical representations that people can interact with to get a better understanding of what is happening, rather than simply learning rules that have no meaning to them. But there's a problem in using an object to represent a negative number. How can you have a something that has a value of less than nothing? Maths resources such as double-sided counters and algebra tiles can be used to represent 0 and positive and negative integers. A counter or a tile represents a value of 1, which when the yellow side is facing upwards represents a value of positive 1, and when it's turned over to the opposite side, which is red, the counter or tile will represent a value of negative 1. A 0 is represented when one red and one yellow tile or counter are together, creating something called a zero pair. But what is a zero pair? In order to solve problems involving positive and negative integers, pupils need to understand this concept of zero pairs. A zero pair is when two opposite numbers, each with the same digit, add together to make 0. To be opposite, one will be positive and the other negative. For example, -1 and +1 are considered opposites as they are equal distance from 0 on a number line. If we start with +1 and add -1, the result is 0. If we start at -1 and add a +1, we also reach 0. This can be represented by having one red and one yellow counter or tile, as a -1 add a +1 is equal to 0. Another example of a zero pair would be -3 and +3. There are 3 counters with the red side facing upwards, each with a value of -1, so all together representing a value of -3. Here are 3 yellow counters with the opposite side facing upwards, now with a value of a +1, altogether representing a value of +3. We can make 3 zero pairs, as a +1 added to a -1 is equal to 0. And we can repeat this 2 more times and make 3 sets of zero pairs. 0 plus 0 plus 0 is equal to 0. While some pupils are able to use algebra tiles or two-colour counters confidently, others find this confusing as they struggle to see how 2 objects, one red and one yellow, that when they're paired up, have a value of nothing or 0. In the next part of this video, I'm going to tell you about our DOTS and TODS counters and explain why we think they're a better alternative to two-coloured counters and algebra tiles, as they provide pupils with a clearer visual representation of zero and positive and negative integers, which are really easy to use. Our DOTS+TODS counters are interlocking black and white counters that are physical representations of piles and holes and dots and anti-dots approaches that are often used in schools to help pupils understand opposite numbers, positive and negative integers, and zero pairs. We can think of a flat surface as representing nothing or zero. When we put a pile on top, it represents a value of +1. Our white dot counters are concrete representations of these piles and each have a value of +1. If we want to represent the value of +3, we could either draw 3 piles or use 3 white dot counters, each with a value of +1, altogether representing a value of +3. The opposite of a pile is a hole, which represents a value of -1. The opposite of our dots are TODS. Our TOD counters are black with a recessed centre to give a concrete representation of these holes. They have a value of -1. If we wanted to represent the value of -2, we could either draw 2 holes or we could use 2 -1 TOD counters. A pile is the opposite of a hole because if the contents of a pile were added into a hole, it would fill it, leaving a flat surface with neither piles or holes. If we had 2 piles with 2 holes, they would in effect cancel each other out, as the 2 piles would fill the 2 holes, leaving us with nothing. This helps us visualize how the same amount of opposite and negative values always add together to make 0. This is called a zero pair. Dots and TODs interlock, so the white +1 dot that acts like a pile can fit inside the hole of a black -1 TOD. They create one object with a flat surface which now clearly represents the value of nothing, and they can even see the symbol of a 0. Here is a simple activity pupils can do with our dots and TODs to ensure they have a really secure understanding of this concept of zero pairs. If I had 2 white dot counters, on their own, they would represent a value of +2. If I had 2 black TOD counters on their own, they would represent a value of -2. However, when we have them all together, this does not represent a value of 4. +4 would be 4 white dot counters. -4 would be 4 black TOD counters. What is actually represented here is a value of 0. We have 2 opposites that will cancel each other out, as we can fill up our holes, our TODs, with our piles, which are our dots. We have created 2 zero pairs, as 0 plus 0 is equal to 0. Pupils need to understand that no matter how many dots and TODs counters they use, as long as there is the same number of +1 dots as -1 TODs, or piles and holes, they will always represent a value of 0, but there will just be more zero pairs to make. Here's another example. Here's a set of dots and TODs that are arranged differently. It is clear to see that there are 3 white dot counters and 3 black TOD counters. However, this does not represent a value of 6. As there are 3 +1 counters, we can combine them with the 3 black TOD counters. We can make 3 zero pairs. So what is represented here is a value of 0. We can prove this by making our zero pairs by placing our +1 white dots inside of our -1 black TODs and make a value of 0, because a +1 added to a -1 is equal to 0, and a -1 added to a +1 is also equal to 0. 3 sets of zero pairs is equal to 0. What about this set of counters? As they're arranged like this, it's hard at first to spot that this group is representing a value of 0. Although there are 10 counters, as we have 5 +1 dot counters and 5 -1 TOD counters, we can make some 0 pairs. And in fact, we can make 5 sets of 0 pairs. As a +1 added to a -1 is equal to 0, we can repeat this and see that we have made 5 0 pairs representing altogether a value of 0. Pupils could continue to investigate making values of 0 with different quantities of dots and tods. When they're confident with the concept of 0 pairs, they will be able to move on to using dots and tods to help them with adding and subtracting positive and negative integers, which we're going to be looking at in the next video.